Before we begin looking at solving our quadratics by several different methods, I want to go through and review factoring a trinomial because we'll use that in solving quadratics, and we also use it in some other things when we get into our rational polynomial expressions. So as we begin factoring our trinomials, I'm going to give you a list of steps that you can go through that will help you factor it, I think, the easiest way. The first thing that you always want to do is to look for a common factor. If you have a common factor, then you can make your polynomial a little bit easier. So let's start with 16x minus 24. Now, when we look for a common factor, in this case, we're going to be looking for a number that will divide both 16 and 24. And we'd like to get the largest one. If you don't get the largest one, then you're going to have to look for another common factor. So the largest number that will divide both 16 and 24 would be 8. So we're going to factor out our greatest common factor of 8. And so what we look for is, what would we multiply 8 by to give us 16x? Well, we would multiply it by 2x. Then what do we multiply 8 by to give us negative 24? And that would be negative 3. So we factored out our greatest common factor. If we look at another one, let's say that we want to factor 6x to the 4th minus 18x cubed plus 12x squared. Okay, we're going to start with our coefficients because in this case we had variables in every term, so we're going to be able to factor out a variable also. But we'll start with our coefficients with 6, 18, and 12. And we want to think of the largest number that would divide all of those. Well, that would be 6. So 6 is going to be our common factor. Then since each of these terms has an x, what we do is we factor out the lowest exponent. So we're going to factor out an x squared. Now we want to go through and find out what our other factor would be. Well, we're asking ourselves 6x squared times what would give us 6x to the 4th? Well, that would be times x squared. Remember, when you multiply like bases, you add your exponents. Then 6x squared times what will give us negative 18x cubed? Well, that would be negative 3x. And then 6x squared times what would give us 12x squared? Well, 6 times 2. Now, when we get through, we should not have a variable in each term. If you have the same variable in every term, then you didn't factor out your largest one. So we have it factored into our common factor. Now, later on, we'll come back and we'll look at how we would factor this trinomial that was left. But right now, we're just going to be looking at factoring our greatest common factor. So if we have this one's going to look a little different. If we have x times 2x plus 1 plus 4 times 2x plus 1. Okay, in this case, our greatest common factor here is the 2x plus 1. Each term is being multiplied by 2x plus 1. So we're going to factor it out, just like we would have factored if this had been x times a plus 4 times a. We would have factored out that a. So we're going to factor out the 2x plus 1. And then we're going to ask ourselves, well, 2x plus 1 times what would give us x times 2x plus 1? Well, times x. And then 2x plus 1 times what would give us a 4 times 2x plus 1 times 4. So you can look for your greatest common factor in several different ways. But that's always the first step that you want to go through as you're looking for your factoring. You want to factor out any greatest common factor. Okay, then let's look at the next thing that we would do. After you factor out any common factor, then you kind of need to know, well, when do I keep going on? Like I said in one of those problems, that we would still be able to factor that trinomial. Back here, I said that we had a trinomial that we would still be able to factor. Well, how do you know when to keep going on and looking for other things? So what you want to do is, if you still have exponents in that term of what you factored, then you're going to count the number of terms to determine your method for factoring. So that's how I knew I still had exponents. So if you still have exponents, you want to count your number of terms. So we're going to start with two terms. If you have two terms, then how do you factor it? Now, these methods are very set for two terms. It's not that they're going to change with different ones. These are the only things that you can have with two terms and be able to factor. You either have the difference of squares, and your factoring is x squared minus b squared. If it's in that form, then it factors to be a minus b, a plus b. And that's the factoring that you will go through. These are called conjugates. We'll also look at difference of cubes and sums of cubes. We won't be using those until later on, but I'll go ahead and cover them at this time. So what you're looking for here is a pattern. And if you have that pattern, then you're going to be able to factor it. So let's start with this problem. If we have x squared minus 144. Now we'll check to see if we have a common factor, which we don't. And what we notice is we have two terms. We still had an exponent, and we have two terms. So we're wanting to see which pattern this would fit. Well, since it's a square, the only one we can look for is difference of squares. So we're wanting to know if we can write this as something squared minus something squared. Well, this would be 8. We want to know, is there any number that when we square it, we get 144? Well, the number 12. So we've been able to write it in that pattern. Therefore, we can factor this to be x minus 12 times x plus 12. It's our a minus b times a plus b. And it doesn't matter. You can put the plus here and the minus here. That's just your commutative property. So we were able to factor it. Let's look at 36 x squared minus 49y squared. Well, we have no common factor. There's not any number that'll divide 36 and 49. But we do have these in the term of perfect squares. So we can factor this. This is the same as 6x squared. 6 squared is 36, x squared, minus 49 is 7, y squared. So we wrote it in the form of a squared minus b squared. So this will factor to be 6x minus 7y times 6x plus 7y. And we have our difference of squares. But they have to be perfect squares. If one of them wasn't, then we wouldn't be able to factor it. If we had as our problem, let's say we had 4x squared minus 3. Well, even though we can write this as 2x squared, we're not going to be able to write the 3 as a perfect square. So we can't factor it. If we had had 4x squared plus 9, well, we can write both of these as perfect squares, but it's not a minus sign. So we're not able to factor it. It has to fit the pattern of a perfect square minus a perfect square. Now, for the sums and differences of cubes, it's just a matter of following the pattern and learning to say it in a way that you're going to be able to remember it. So if, let's take 27x cubed minus 1. Okay, there's no common factor, and we're going to follow our pattern. We have two terms. This is a perfect cube. This is 3x cubed, and 1 is a perfect cubed. It's 1 cubed. Now, the pattern that we follow, and it's kind of up here, but if you went back to it and looked at it, if we want to follow that pattern, it says if it's in the form of a perfect cube minus a perfect cube, then it's what we cubed minus what we cubed. So it's the a minus b. And then I like to say then it's the first term squared. We change the sign. It's the product of these two terms plus the last term squared. And I find if I say it in those words, then I get to say the same words each time. So as we factor this, it's going to be what we cubed, so 3x, the same sign, so minus what we cubed, which is a 1. That's going to be our first term. To find our second term, we take this first term and we square it, which would be 9x squared. We take this sign and we change it, so it would be a plus. Then we're going to multiply these two terms together. 3x times 1 is 3x. Then it's always a plus the last term squared, which would be a 1. Now, even though this still has an exponent, you will never be able to factor this part again. It will not be a trinomial that would factor. Let's look at a different one. Let's take x cubed plus 64. Well, there's no common factor, but we have an exponent. We have two terms. Since it's a cube, we're going to look for something cubed plus something cubed. Well, 4 cubed is 64. So we can write it in that form, therefore we can factor it. It's what we cubed, same sign, what we cubed, times. Okay, we're going to square the first term, change the sign, multiply our two terms together, plus the last term squared. And let's look at just one more. Let's look at 8x cubed plus 125. Okay, there's no common factor, but there's two terms, and it's cubed, so I'm going to see if I can write it as the sums of cubes. So this would be 2x plus, and 5 cubed is 125. Now, if you can't write it in the form of the sums of two cubes, then you can't factor it. So our factoring is going to be what we cubed, same sign, what we cubed, times, we squared this first one, which would be 4x squared. We multiply these two terms together. Oh, excuse me. We're going to change our sign. Then we're going to multiply these two terms together, which would give us 10x. Then plus the last number cubed, the last term cubed, which would be 25. So this is our method for factoring when we have two terms. And these are the only ways we're able to factor when we have two terms other than a common factor. Okay, what we want to look at next is, well, what do we do when we have three terms? Okay, with three terms, what you do is you look at your leading coefficient. That's what's going to determine it. Either your leading coefficient is 1 or it's not 1. So let's look at the ones where it's 1 first. If your leading coefficient is 1, then you're going to go straight to your parentheses. And you're going to find factors of C that combine, either add or subtract to be B. And we'll look at to see how we know which one that is. So let me just get a different page instead of scrolling down on this one. So let's start with one that, let's start with this one. 8 or x squared minus 8x plus 15. Now, your signs here are a big clue as to what you do. Okay, first of all, there's no common factor. We have 3 terms, and our coefficient is 1. So we're going to be able to put our parentheses, and we're going to put an x and our x's. Now, these last two numbers here, if you remember when we multiply our two binomials, these last two numbers multiply to be this number. So we're wanting two numbers that multiply to be positive 15. Well, our choices are 1 and 15 or 3 and 5. And we need to know, well, which ones do we pick? So we look at our sign. It's a positive. That meant those two signs were the same. They're either both pluses or they're both minuses. Well, we get the middle number by combining them. So we think of our rules for addition. If the signs are the same, you add. If the signs are the same, you add. So since this was a plus and it told us that our signs were the same, then that means we're going to add to get 8. So we wanted them to multiply to be 15, and we wanted them to add to be 8. Well, these add to be 16, and these add to be 8. So these are the ones we're going to use. Now, we need to know, well, is it a positive, did we get a positive 8 or a negative 8? Well, we look over here and it says we got a negative 8. So our signs were the same, so we added and got negative 8. So that meant they had to both be negative. So what we're going to put in our parentheses then is a -3 and a -5. Now you could always check these by multiplying them back through using your distributive property. X times x is x squared. X times -5 is -5x. -3x times x is -3x. -3 times -5 is a +15. And then you can see that we added those. The signs were the same, so we added, and our answer kept the same sign. All right, let's look at another one. And let's say that we have x squared minus 2x minus 15. Well, there's no common factor. We have a coefficient of 1, so we're going to go directly to our parentheses. Now, here again, these last two numbers multiplied to be 15. So that lets us know it's going to be 1 and 15 or 3 and 5. But notice it's a negative 15. That tells us that our signs were different. One's a plus and one's a minus. One's a plus, one's a minus. If the signs are different, then remember, we subtract. So we want to subtract to come up with a -2. Well, if we subtract these, we're going to get 14. If we subtract these, we're going to get 2. We want a -2, so that meant it had to be a -15 and a +3. So we have a +3 and a -5. And again, we can multiply those back through. Let's just do that. X squared minus 5x plus 3x minus 15. And you can see then we would have x squared minus 2x plus 15. So when our coefficient's 1, it's not too difficult to do. So let's go back. If our coefficient's 1, then we're going to go directly to our parentheses and find factors of c that combine to be b. But if our coefficient is not 1, if our leading coefficient is not 1, it's some other number than 1, we're going to use what I call the AC method. And we're going to find factors of AC that combine to be b, and then factor by grouping. So let's just go back and look at one of these pages. Let's just clear this page. And we're going to look at ones where the leading coefficient is not 1. So let's start with this one. We'll start with this one, if I can get a pen to start. Okay, so we've got to have 2x squared plus 5x minus 3. In this case, we did not have a common factor. There's no common factor for 2, 5, or 3. And our leading coefficient is not 1. So what we said we would do, this is in the form of ax squared plus bx plus c. We're going to multiply our coefficient a times our constant c. So 2 times negative 3, that gives us a negative 6. Now, because it's a negative, that tells us that our signs are going to be different. Now, we want numbers that multiply to be 6. So that would be 1 and 6 or 2 and 3. The signs are different, so that means they're going to subtract to be 5. We want to find a difference of 5. So 1 and 6, their difference is 5. 2 and 3, the difference is 1. So we're going to use the 1 and the 6 because they have a difference of 5. Now we wanted it to be a positive 5 because that's what it tells us in our problem. So that means we needed a negative 1 and a positive 6. Now we haven't put any parentheses yet. What we're going to put here then is a negative 1x and a positive 6x. All we've done is we've rewritten that 5x as negative 1x plus 6x. We're going to write down our first term, and we're going to write down our last term. We've just rewritten that middle term. That's all we've done. Now we're going to factor by grouping. We're going to take these first two and look for a common factor. Well, the common factor for those first two is x. So we have x times 2x would be 2x squared. X times negative 1 would be negative 1x. Put down whatever sign we have between those two terms, which is a plus. Then we're going to look for a common factor for these two terms. Well, for those two terms, it's a 2. It's a 3. Let me just erase that. Okay. It's a 3. So 3 times 2x would be 6x. 3 times negative 1 is negative 3. Now, if you notice, what we have here are common factors. So we can factor out that common factor of 2x minus 1 times x plus 3. And we have our trinomial factored. We could go back through and multiply it to check it, but we have it factored. Okay, let's look at another one. Let's say that we have 6x squared minus 17x plus 12. Okay, there's no common factor for all three terms. My leading coefficient's not a 1, so I'm going to use my AC. 6 times 12 is 72, and it's a positive 72. That means our signs are going to be the same. If our signs are going to be the same, that means that we're going to add them to be 17. In fact, to add to be a negative 17. So that tells us our signs are the same and they're both going to be negatives since we end up with a negative 17. So if we go through, if we're not sure, if you see them right off, it's okay. If not, you go through and you list factors of 72, 1 and 72, 2 and 36, 3 and 24, 4 and 18. Those add to be 22. None of them have added to be 17 yet. 6 and 12, Oh, that adds to be 18, and 8, and 9. And those are the ones that add to be 17. And since it's a negative 17, we need them to both be negative. Negative 8 times negative 9 gives us a positive 72. Negative 8 plus negative 9 gives us a negative 17. So we're going to write down negative 8x, negative 9x. Now, it doesn't really matter here. You could have put the negative 9x, then the negative 8x, and you'll get the same answer. So don't worry about which order you write them down in. What's important is you get the right sign with each term. Then we write down our first term and our last term. We're going to factor. With this first group, we have a common factor of 2x. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. Now notice my sign's a negative. I'm going to have to watch some things. Common factor for these two is a 3. So negative 3 times 3x would be 9x, negative 9x. Negative 3 times negative 4 is 12x, a positive 12, excuse me, not 12x, but just a positive 12. So notice since I factored out a negative number, that sign inside changed. It has to be the same for me to be able to then factor out my common factor of 3x minus 4 times 2x minus 3. Okay, let's do another one. Uh, let's take this one. 5x squared plus 13x plus 6. Okay, there's no common factor. I have 3 terms and my coefficient's not 1. So I'm going to have to multiply. 5 times 6 is a positive 30. So I want numbers that multiply to be 30. Since it was a positive 30, my signs are the same. So I'm going to add them to get 13. And it's a positive 13, so that lets me know that they're both pluses. So my factors of 30, 1 and 30, 2 and 15, 3 and 10. There's the two that add to be 13. Now notice 2 and 15 subtracted to be 13. So that's why it's real important that you pay attention to your signs. We wanted them to add to be 13, so we're going to use the 3 and the 10. Signs were the same, and they were both pluses. The reason we know they're both pluses is because it's a plus 13 over here. So we have 3x and 10x. They're both pluses. All we've done is rewrite 13x, which I left that x off, didn't I? 13x as a sum of 3x plus 10x. We haven't changed our equation, we just rewrote it. We haven't changed the value. Okay, our common factor here is x times 5x plus 3 plus our common factor here is a 2 times 5x plus 3 plus 3. So we have 5x plus 3 times x plus 2. Okay. Now let's say that we have 6x squared minus 5xy minus 6y squared. Okay, it's not going to matter that we have more than one variable. We look for a common factor. Then we're going to our coefficient's 1, so we'll multiply, and what we get is a negative 36. And you can put the x squared, y squared. I'm just dealing with what our coefficients need to be. Since those were both squared, we're fine. So we want numbers that multiply to be negative 36, so they will subtract to be negative 5. We want their difference to be negative 5. Well, our factors of 36 1 and 36, 2 and 18, 3 and 12, 4 and 9. 4 and 9, those are the two that will subtract to be 5. And since we want it to be a negative 5, it's got to be a negative 9 and a positive 4. So what we're going to put here is a positive 4, and then we're going to put xy because that was the variables that went with the middle term, and a negative 9xy. Remember, these two have to combine to be this middle term. Write down our first term, write down our last term. Then we're going to do that factoring by grouping. We have a common factor of 2x. Well, 2x times 3x would be 6x squared. 2x times 2y would be 4xy. Minus, so now we're going to have to watch our signs again. Our common factor would be 3y. So negative 3y times 3x would be negative 9xy. Negative 3y times positive 2y would give us negative 6y squared. And a way of checking it, these have to be the same. If they're not the same, you've made a mistake. It's not that it's not factorable, you've made a mistake. If there's numbers that multiply to be negative 36 and subtract to be negative 5, then it's going to be factorable. And so this would be 2x minus 3y. Okay, some things that work out real nicely with these. If you factored before, you may have talked about trying to find if it was a perfect square. But notice if we have 9x squared minus 12x plus 4. Okay, there's no common factor. If we multiply 9 times 4, we get a positive 36. Since it's positive, it means we're going to add to get negative 12. Well, if we went through and listed our factors, and if you see them right off, you don't have to list them, but 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Well, those are the ones that add to be 12, and that have to both be negative. When these numbers are the same, when the factors are the same, what that tells us is that this is a binomial squared. So we can go back through then and ask ourselves, well, what squared is 9x squared? Well, 3x. And then it's going to be a minus because it's a minus there. And what squared's 4? 2. And then you could go back through and you could multiply it by the product. It's the first term squared, then twice the product of the two terms, plus the last term squared, or multiply it out. But when those numbers are the same, that's what tells you that it's a binomial squared. So this works even for those, and you didn't have to check, well, is a perfect square, and is the last term a perfect square, and is the middle term twice that product? You got it as you went through. One more that we want to look at, 4x squared minus 8x minus 15. Okay, there's no common factor. We have a coefficient that's not 1, so 4 times 15 is 60. It's a negative 60. We want factors then that multiply to be 60 and subtract to be negative 8. Well, our factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15. Those aren't subtracting yet. Those subtract to be 11. 5 and 12. Those subtract to be 7. 6 and 10. Those subtract to be 4. 7 won't. 8 won't. 9 is not a factor. 10, and so we've already started. We've got all of our factors. If you go through in order, then you know if you've gotten them all. And we did not have any that subtracted to be 8. We had 4, 7, 11, and notice these get smaller as you go down. So since there were no factors of 60 that subtracted to be 8, then this is not factorable, or we can call it prime. So you know then, if you have something that's not factorable. All right, we've got one other way that we need to look at, one final thing. If you've got 4 or more terms, then you're going to factor by grouping, which is what we just did with our 4 terms in that case. So all that you're doing if you've got 4 or more is doing that factoring by grouping, which would be a matter of taking a problem such as x cubed minus 3x squared plus 4x minus 12. And you're going to group them. So we're going to do it in groups of 2. We have a common factor of x squared. That would give us x minus 3 plus, we have a common factor of 4, x minus 3. So we could factor this to be x minus 3, because that was our common factor, times x squared plus 4. Now, we still have an exponent. It's a square. We have 2 terms. So with 2 terms, remember, we look for the difference of squares, but this is the sums of squares, so we cannot factor that any further. But it's just doing our factoring by grouping. X cubed minus x squared minus 5x plus 5. Okay, there's no common factor. There's 4 terms. We're going to do it by grouping. In this first group, we could factor out an x squared and have x minus 1. Where we can factor out a negative 5. So negative 5 times x is negative 5x. Negative 5 times negative 1 is a positive 5. Well, these factors are the same, so we can factor out an x minus 1 times x squared minus 5. Again, we still had an exponent, so we would check. We have a perfect square. We have a minus sign, but 5's not a perfect square. So that's as far as we can go. So these are our steps then that will factor our trinomials. And most of what we will be using are the 2 terms, difference of squares, and the 3 terms. So hopefully this will help you then as you go through and are trying to factor.